I want to make this video about the ghosts of gravity. In these early days, they didn't know anything, so all the stuff they did, this was complete nonsense. So the math here was pretty basic, and the physics was mostly fake. So let's start with just some basic math. Back from 3000 BCE was when the numerals were first invented in Sumeria. So we can see the Sumerian cuneiform. This is like a little tablet right here. So all they had were these two numbers, 1 and 10. And so from there, they were able to count stuff. That worked out pretty well for until it was updated in like 1800 BCE. Um, so then they expanded these numbers. If we look at the Egyptian hieroglyphs, this was another one that was made, and you can see down here the little stone that they drew. This isn't, I can't really see if there's any numbers in here, but this is kind of the types of symbols that they would be using to mark these. You got 1, 10, 100, 1,000, 10,000, even up to a million there. So this is the earliest form of mathematics, which was pretty cool. We now go to 2000 BC or 1000 BC, somewhere around here, where these very early civilizations like Mesopotamia and Egypt, they were starting to come up with some mythos. So mathematics came actually before the mythos, but now we're thinking about the age of mythology, where we've got, Mesopotamia believes that Earth is flat, and there's an underworld below, and there's heavens above. So this is a little Mesopotamian uh, image here. You can see some of those deities and demigods that they might have had. And in Egypt, they were thinking also that the earth was flat. It's a manifold, so it looks to us like it's flat, right? You can't see the curvature. And then they thought that there was like a sky goddess, an air god, underworld, or the primordial waters, right? No, they didn't have any physics equations. So they just had like symbols and stuff like this, like little squares and circles and triangles, objects, geometry, these kinds of things. They made some star charts and calendars. They didn't have any, besides those basic number systems. They didn't have any real equations yet. So mythology was explaining everything, and they didn't have any kind of experimental method. So people could just say whatever they wanted to, and it was true. All right. So that was this is Egyptian tablet. You can see some of their belief systems and more hieroglyphs. So then we move over to 600 BCE when we started having some of the first philosophers like Thales of Miletus. Um, this was interesting because he thought that water was the fundamental substance. It makes sense because if you're not drinking, then you're gonna die. It's essential for life, and it changes forms from solid, liquid to gas in these different ways. So it's such a complicated uh, compound that, you know, I guess it's a molecule, but the idea is that he thought, Thales of Miletus thought that it was the most important compound of substance on Earth, that land floats on water. What's this big theory here? Just land floating on water. Because water, from as far as the eye can see, and we just have land floating on water. That was his idea. He didn't have any equations, and but what was important is that this was a non-mythological idea. Most people back in the day were thinking about gods, deities, mythos, all that cool stuff. But he was one of the first to say, you know what? Maybe it's just land floating on water. Maybe water is just the most important thing, you know? So that was Thales. And around the same period, 600 BC, we had Anaximander of Miletus. They may have been pupils or something. But he kind of went a little further, and he was saying but there's this stuff called Apeiron. It's not water, but rather Apeiron, undefined or eternal source of power or energy or something. And that Earth doesn't float on water, but it floats symmetrically in space. It's the skies, it's floating in the sky rather than on water. Interesting. He also taught the opposites balance, so we kind of have this image here. He might have been looking at these types of things and thinking to himself, yeah, there's hot and cold, wet and dry, up and down, all these things balance each other. That's why there's symmetry. That's why Earth floats symmetrically in space. you know. And then we've got stars. This is what he thought the stars were circular vents in the sky, like cutout vents that just shine through. So that was his idea, all right. He even came up with sort of this concept of net force equilibrium. This is one of the very first, like, almost legitimate theories that if you have balancing forces, then you're in equilibrium. It's kind of statics, the basics of statics. But the circular vents in the sky is pretty impressive. Like, this stuff was like, what? You think stars are cutout vents in the sky? I mean, what? What's going on here? That was Anaximander. Some of these ideas that we think to ourselves that they may not seem like very good ideas. They're completely wrong, right? But maybe there's something here that like later we can use, maybe mathematically describe it, and we can get some footage, like some mileage on a problem, even if it's not the correct answer, like we get something out of it. So that's like it's like finding like the silver lining in the dark cloud. That's what some of these ideas are. Like even though you have a bad thought, it's a dark cloud, is not right, but there's something right about it. We'll see how the circular vents may come into factor a little bit later. But now we go to Pythagoras. This was a pretty important person. So he made the Pythagorean. Well, he didn't really make the Pythagorean theorem. This was actually known a long time ago before him, Pythagorean theorem. He just made it popular for whatever reason. He drew out these uh, the triangle from a couple of different squares. He didn't have an equation, so how do we get c squared equals a squared plus b squared? I mean, he just kind of wrote it down and was like, you can take uh, square all three sides of the triangle, and something like that. So he basically all the equations from back in the day were written out in written form. Like people would say stuff, write stuff. Um, but he had an interesting idea that numbers describe universal structure. He was thinking about proportions and ratios, and he actually came up with the idea that Earth might be spherical. So that was kind of a new idea. Remember, the Earth seemed to be flat, that he thought it was a sphere. All right, so important contributions from Pythagoras. And now, well, they had upgraded their numeral system by about 500 BC. This is when the Greek numerals came along, and Braille numerals came a little bit later, as well as the Roman numerals even later. These are some of the types of things that they were writing, just other number systems. You can see engravings here. H, G, and this epsilon. That means 256. And over here, we have some Roman numerals. This H, or sorry, Greek numerals. Might have been, I think this is Greek numerals here. This is Greek, right? So HHH must have been 300 or something there. This thing, I don't know what that is. It might have been 5. But so there you have some more numeral systems that were invented around 500 BC. Pretty cool stuff. Now we go back to some philosophers like Anaxagoras of Clazomenae. He was in 400 BC. We're just advancing through the centuries here, I suppose. And so he continued this idea that maybe the universe is some sort of a uniform mixture rotated by cosmic intelligence. That's some kind of strange theory here that it's like rotating, and that because of this rotations, there's this like centrifuge like sorting going on in the universe. Like everything's being sorted by the centrifuge. And the Earth happened to form at the center of the centrifuge. But this is the universe mixture, like the uniform mixture, rotated by some cosmic intelligence. This is too funny. So all these theories are so strange. But I mean, it's technically almost correct. Like, when you got, I was thinking the other day, how can we not feel how fast we're spinning through the universe at like insanely fast speeds, and yet we can't even feel that speed. It's crazy. But anyway, he also thought of the ideas here that were pretty important ideas. The moon reflects light. You know, um, he was seeing from the eclipses that the moon actually might reflect the sunlight. Like it made sense to him. And the meteorites, he like saw a meteorite fall from the sky. It was like a big, big meteorite that lasted several days or several weeks, and he watched it fall eventually. And he came to this conclusion that meteorites must come from space. It was so obvious, but these things are just like people didn't think that meteorites came from space before. They thought it was some like uh, some deity or some god that was angry and throwing rocks or something like that. So Anaxagoras was a big thinker, came up with some brilliant ideas. Moon reflects light. That's actually real physics. So first glimpse of like actual real physics here, I suppose. Next person was Democritus of Abdera, around 4000 BC. Just gonna just check real quick to see if anybody said anything. But yeah, Democritus of Abdera, around 400 BC. Uh, this person really important because they came up with the concept of atoms. This was like so important. Well, Democritus, I think, was probably the first person ever to think about things as being indivisible atoms. This is kind of the picture of what I think he probably was thinking about things at that time, like really just small little rocks or something that just, you can't break them apart. They're little bits. And there's no gods for him. There was no reason. There was nothing except just matter and motion. So that is pretty powerful thinking way back in the day. Well, this was already 400 BC. You know, the age of mythology had already essentially passed. We're in 400 BC. You know, we're starting to become more like real religions, I get more modern day religions, I suppose. But so the idea of the atoms is that they can have multiple, the different sizes and shapes and speeds. They have collisions and combinations, but there's no creation or destruction. It's just a rearrangement of all this. But he was wrong because there was no fields and no forces in his model, no vacuum pressure, nothing of the modern day physics. It was just atoms, right? So that was his brilliant dis thinking. He didn't really discover it. He thought about it. I wonder why he thought that everything was made of indivisible atoms. He was probably just cutting everything and just came to this conclusion eventually. Anyway, Democritus, really important, 400 BC. Democritus of Abdera. Then we move to Plato of Athens, around 380 BC. Plato, this guy, it's interesting how they kind of all look very similar. So he, again, started to think that, you know, sort of following this idea. Well, maybe water is the fundamental structure. Maybe it's rotating around everything. Maybe there's this fundamental force. He was thinking the universe is just an imperfect copy of an eternal mathematical order. So again, along the lines of I think Pythagoras, he was thinking that numbers describe the universal structure. He thinks that the universe is an imperfect copy of eternal mathematical order. And you know what? I think this too. I think that the universe represents, it's like an imperfect copy because I don't know, we have these equations, but these equations aren't perfect. Like they always have some approximation error, right? Like there's always some error to our equations. So it seems to be some kind of an imperfect copy. Or maybe not, but I don't know. So Plato thought that matter was made of Platonic solids. So we had these five. We had fire, air, water, earth, and the cosmos. So you can see the shapes like the tetrahedron, the octahedron, the icosahedron, the cube, and the dodecahedron. These were the things that he was thinking that was making matter. So he was maybe trying to find the shapes of the atoms, the shapes of the things that were like building these things. But it doesn't seem he probably didn't seem to think about atoms. He thought tetrahedron was fire, octahedron was air. So a little bit weird, but these are the Platonic solids. And then we have his form of math, which was only shapes, ratios, and symmetry. There again wasn't any real equations that they were making at this time. It was just observations based off of shapes and ratios and symmetries, and they just wrote down what they thought was right. And this is Plato of Athens. We move to Aristotle of Stagira. This is in 350 BC, and see that. his idea was that objects seek a natural placement, natural order. So the heavy objects move down, like earth and water. Light objects, like air and fire, move up. And again, this was just some of his theories and written ideas. He thought that there was a finite universe, although I think now we know that the universe is infinite. And he came up with the idea of circular orbits. So this is very important. He started the idea of things orbiting. They were all orbiting around the Earth. The sun orbits around the Earth. And it almost seems like that, right? If you start looking out, it seems like the sun is orbiting around the Earth and that the moon is orbiting around the Earth. Well, the moon is orbiting around the Earth. We can't tell that the Earth is orbiting around the sun. It just looks like another moon to us. So it's kind of weird. But this was his idea that he started to think of circular orbits. He also thought that velocity increases with applied force and decreases with resistance. So it's almost like a proto-Newtonian physics, F equals ma, type of thinking. Although there wasn't an equation, and this isn't correct. So, it's close, but it's not correct. This was Aristotle of Stagira, important thinker. When we come to the final stage here, around 600 CE to 1000 CE, when this is kind of the last bit of nonsense that people were thinking about. In fact, they started to come up with great ideas here. So in India, Brahmagupta, in 628 CE, he realized, or he thought that objects fall towards the center of the earth. And technically, that is true. He didn't come up with, but I mean, seems to be like one of the very first ideas of actual gravity, where it's like, whoa, objects might actually just be falling towards the center of the earth. And it is actually correct. He didn't explain why, but now we can pretend this is our little Earth right here, and that the objects are falling towards the center. He also came up with zero and negative numbers. Oopsie. So zero and negative numbers. This was just powerful because before we didn't have zero. We couldn't even explain what zero was. Before they didn't have negative numbers. They thought it was just nonsense. And so Brahmagupta, he came up with zero, negative numbers, and an idea for gravity, like the proto-gravity idea. This was in India. And then I think that this was, I guess we have three Islamic, um, so there was one from India and then three Islamic ones here. We have Muhammad al-Khwarizmi. He's a really important person. He was the, I guess, this is where our algorithms come from, right? Al-Khwarizmi. He came up with like linear and quadratic equations, all written form, of course, so there was no real equations. And I think he came up with some like unknowns, like variables types of things. But this was Muhammad al-Khwarizmi back in 820 CE or so. We also have al-Biruni. It's this guy right here. He measured the radius of the Earth somehow, probably using like shadows and angles and stuff. So that was kind of crazy. We also had another person, Avicenna, who thought of momentum as motion continuing unless resisted. So these are sort of almost coming towards realistic physics now. It's around 600 to 5000 BC. Sorry, this is CE, after Christ, Common Era, around 1000 CE, so 1000 years ago. This is when we started to really almost come up with correct ideas, although not quite exact, so not enough to put them into the second category of nearly accurate. So we'll have to take a look at this in the next video. The idea is that this is sort of the final moment of nonsense, complete nonsense. And that's why the text here is all red. We shouldn't really be believing any of these people from back in the days over here, the complete nonsense, the Numerals, the Mesopotamians, Thales, Anaximander, Pythagoras, Anaxagoras, Democritus, Plato, Aristotle, and then India and Islam. They all made great contributions, but it was all pretty much complete nonsense. So thank you all so much for watching, and we will check some more out in the next video.